Hey everyone, today I'm going to teach you how to find the empirical and molecular formulas for a compound. So we'll begin with the empirical formula. First of all, you need to know that the empirical formula is the lowest whole number ratio of atoms in a compound. So for example, if you had the formula C2H6 and I asked you to tell me the empirical formula, you would need to reduce it to the lowest form possible. So both of those subscripts can be divided by 2, and so the empirical formula would be CH3. In this example, Mg2O2 can be reduced to MgO. That would be the empirical formula. This is just saying that once you have the empirical formula, it cannot be reduced anymore. And the reason we need to know how to find the empirical formula is it's going to help us with our math. The ratios will be the same. In a lot of our examples, you will be given the percent composition of a compound, and you are supposed to find the subscripts from that. So you can sort of think of this as the opposite of finding the percent composition. In our previous notes, when I taught you how to find the percent composition, you were given the formula, so you knew what the subscripts were. And from that, you found the percent composition. Well, in the examples you'll be given for this part of our unit, we'll be doing the reverse. You'll be given the percent composition, and you have to work backwards to figure out the subscripts. So, the first thing you need to do is assume that the percents given to you in the problem is the same thing as grams. And you need to convert those grams into moles. And hopefully you remember how to do that. Going from grams to moles, we divide by the molar mass. After all of your elements are in moles, you need to divide all of them by the smallest number. And so that is, after you have converted them into moles, whichever one is the smallest, you're going to divide them all by that number. Now, if you get a whole number for each one after that step, then you are done. Those are your subscripts, and you have found the empirical formula. But if you have a decimal, then you need to multiply all of your subscripts by the same number, some sort of multiple that will give you a whole number. So if one of your subscripts is 1.25, you'd need to multiply them all by 4 to get that to be a whole number. If one of your subscripts is 1.5, then you need to multiply them all by 2 to make that a whole number. If one of your subscripts is 0.3, then you need to multiply them all by 3. So I know this probably doesn't make a whole lot of sense without doing a problem, so that's what we're going to do now. We're going to switch over to an example. So this says, what is the empirical formula of a compound that is 25.9% nitrogen and 74.1% oxygen? So let's go to my document camera, and I've written out this same problem. And the first thing we want to do is assume that these percents are the same thing as grams. So for nitrogen, I'm going to write 25.9 grams. For oxygen, I'm going to write 74.1 grams. Now we need to convert both of these into moles by dividing by the molar mass. So for nitrogen, the molar mass is going to be 14, and for oxygen, the molar mass is going to be 16. All right, so when I divide 25.9 by 14, I get 1.85 moles. And when I divide 74.1 by 16, I get 4.63 moles. And I would encourage you, when you do this, to pay attention to significant figures. Whatever they give you in the problem, you should stick to that same number when you're dividing and multiplying. So notice that my answers both have 3. All right, step 2 is to divide by the smallest number. So you're picking the smallest of these two numbers. So 1.85 is the smallest. So I'm going to divide both of these by that. And I get 1 4.63 divided by 1.85 gives me 2.5. All right, so this is the situation I was talking about. After this step, you should get whole numbers. If you don't, then you need to multiply by some multiple to give you whole numbers. Since this is 2.5, I know if I multiply by 2, that will give me 5. That's a whole number. But I've got to do the same thing to my other subscript. So multiply that by 2, and I get 2. So my subscripts now are N2O5. And just to check, remember this is the empirical formula, so those should be the smallest ratio possible. And they are. I can't reduce this any further. So that is how you find the empirical formula. So going back over to our PowerPoint, now I'm going to teach you how to find the molecular formula. So the molecular formula is the true formula of the compound. And it's usually a multiple of the empirical formula. So for instance, CH3 is an empirical formula, but it could be that the true formula for that compound is a multiple of 2, which would be C2H6. So your steps for finding the molecular formula, keep in mind that it is a multiple of the empirical formula. So it should also be a multiple of the empirical formula's mass. Now, in order to find the molecular formula, you have to know its molar mass. You have to be given that information. So then what you can do is find the molar mass of the empirical formula that you just calculated. And when you divide those two numbers, the molar mass of the molecular formula divided by the molar mass of the empirical formula, you will get a multiple. And that's what you'll use to multiply by the subscripts and get your molecular formula. So here are your steps. First, you're going to calculate the empirical formula if you're not given it. Then you're going to calculate the molar mass of the empirical formula. Take the real molar mass, that's the one given to you in the problem, that is the molar mass of the molecular formula. Divide by the molar mass of the empirical formula, and then you will get a multiple. That's what you'll multiply your subscripts by. So let's look at an example, and this example is one that would turn up in a lab that you would do for this type of stuff. So let's look back at our document camera, and you'll see I've copied that same problem. It says analysis of 10.15 grams of a sample of an unknown compound contains only phosphorus and oxygen. And it has 4.433 grams of phosphorus. Experimentation shows the molar mass of the compound is 283.89 grams per mole. What is the molecular formula? All right, so you have this unknown compound, and the problem tells you that this unknown compound is only made up of phosphorus and oxygen. So I'm going to put X and Y as the subscripts, because we know what it's made up of, we just don't know how many of each atom. Well, you know that the mass of this entire thing is 10.15. And you also know that 4.433 of that is phosphorus. So the law of conservation of mass tells us that the other part, if you subtract those two numbers, the other part should be the mass of oxygen. So we're just going to subtract those two numbers, 10.15 minus 4.433, and we get 5.717 grams of oxygen. So now we're kind of at the beginning of our empirical formula problem, like we did up top. You have the grams of phosphorus and the grams of oxygen. I'm going to list those out here. 4.433 grams of phosphorus, 5.717 grams of oxygen. Now we're going to convert both of those into moles. So I'm going to divide by the molar mass of phosphorus. If you need to see what that is, we can look at our periodic table here. So 30.97. And then for oxygen, it's just 16. So we'll go ahead and do that. So for phosphorus, I get, and I'm going to round this to 4 significant figures, so 0.1431. For oxygen, I get 0.3573. Remember, this is moles. And now I need to divide both of those by the smallest number, which would be the one next to phosphorus. Get 1 here. And for this one, I get 2.5. So we know what to do here. Multiply both of those by 2. 2, 5. So the empirical formula for this compound is P2O5. Now I need to find the molar mass of that. So 2 times 30.97 plus 5 times 16. Let's see what we get. (141.94 grams per mole). All right, so we're almost done. Now we need to take the molar mass given to us in the problem, 283.89, divide it by the empirical formula mass, 141.94, and let's see what multiple we get. You can probably already tell. We get 2. All right, so what do we do with that number? This is the number we're going to multiply by our subscripts. So P2O5 times 2 gives us P4O10. And that is the molecular formula. All right, some other notes about this. In your calculator, you'll notice sometimes you get 1.99. You might get 2.01. All of those are close enough to round to a whole number. It should be pretty obvious if it's a decimal that you need to do something with as far as multiplying by a multiple. But if you have any questions, let me know. I know you have a worksheet to do today, and there's a key attached to that. So just let me know if you have any issues.